Welcome to ClickMyProject.com. Now we are going to discuss about the project Comparative Analysis of Intrusion Detection System and Machine Learning Based Model Analysis through Decision Tree. Now we are going to discuss about the abstract of the process. Intrusion detection is one of the important security in today's cyber security world. A lot of techniques have been developed which are based on the machine learning approach. So for identifying the intrusion, we have designed the different machine learning algorithm such as the logistic regression, that is LR, then K nearest neighbor, that is KNN, and then the decision tree, that is the DT. The experimental result shows that the accuracy for both the algorithm is well and good. A network-based intrusion detection system, that is NIDS, is usually placed at network points such as the gateway and routers to check for the intrusion in the network traffic. In this process, we have presented the dataset which is named as the KDD Cup IDS dataset, was taken from the dataset repository, which is used to classify whether the data is normal or the intrusion dataset. Here we have implemented the three stages of the project such as the pre-processing, data splitting and classification. Finally, the performance will be evaluated for the classification for those three above mentioned algorithms like logistic regressions, KNN and decision tree. By using the accuracy, we can justify our processes well and good. Based on the accuracy only, we can able to compare these three algorithms. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this project. This project consists the flow such as the input data, pre-processing, data splitting, classification, prediction, then finally performance analysis. At first, the input data is taken from the dataset. The dataset consists the data of the KDD Cup dataset, which is in the form of CSV file format. After getting the input data from the dataset, the pre-processing will be carried out. In this pre-processing, we have three stages of pre-processing will be there. One is the handling the missing values, then the second one is the label encoding, then the third one is the drop unwanted columns. So here the label handling the missing value is to check whether the missing data is present in the dataset or not. For example, I am giving the one dataset in the form of a CSV file format. Whether the data is missed or else any attribute is missed in that particular column or row, in the sense that will be considered as missing values, those data will be eliminated. After checking the missing values, we have to do the label encoding. Label encoding is simplest form of transferring the text into a numerical form. So when I am giving the attribute in the form of a text string, in the sense it will convert into a numerical form, that is the label encoding. After doing the label encoding, drop unwanted columns will be there. For example, we are giving the lot of attributes, we are giving the lot of columns in the dataset, but some of the several data column are not used in the process, in the sense that will be considered as an unwanted columns. So those columns will be dropped during this pre-processing stage. After doing the drop unwanted column, data splitting will be carried out. In this data splitting, we have two stages of data splitting. One is the test data and then the train data. For example, we have giving the thousands of data, in the sense 80-20 ratio, in the sense the 80% of data will be the train data, 20% of data will be the test data. So the 800 data will be the train data, 200 data will be the test data. After doing the splitting of data, we just move to the classification stage. In this classification, we are using the logistic regression, KNN and decision tree. So the majorly consideration KNN and decision tree for the comparisons. After doing the classification, the prediction will be carried out. In this prediction, we are able to find out whether the data is attack data or else the non-attack data. So after predicting the data, those results will be displayed on the console window. After doing the prediction everything, the performance analysis is carried out based on the accuracy, precision, recall and F-score. Now we're going to discuss about the running procedure of the process. At first, open the Spider 3.7, that is belongs to the Anaconda 3. After doing the opening the software, we have to change the current directory. Then we have to execute the file, main file. After executing the main file, we have to select the data set. Once the data set was selected, the selected data will be displayed here. This is the first step of the project, that is the data selection. We have selected the data's KDD cup. After the selection, those text will be displayed like this. Then the second stage of the project is pre-processing. Among the pre-processing, one of the steps is the checking the missing values. So first of all, we have to check whether the missing value is present in the particular attribute or not. First attribute is the duration, then the protocol, services, flag. So lot of attributes will be there. We have to check whether the missing value is present in that particular attribute or not. In case if there is no missing values is there, means that is not at all problem. In case of any missing value is there, means that should be the neglected. After checking the missing value, we have to encode the labels. So before label encoding, you can see the results like this: label as normal, 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 or in case of attack. So after doing the label encoding, it will replace as an 11. So this will be transferred into a numerical form. So this is the label encoding. You can see the difference here. After doing the label encoding, the min-max normalization is applied to drop the unwanted columns. So in case of unwanted column is there present in the dataset, those attributes will be completely eliminated from this dataset. That will be the drop unwanted column. You can see the results, as well as it will convert the normalized image data. After doing the min-max, we have to split the data into one test and train data set. This is the total number of the input data. So you can see the total numbers. After doing this one, the train part is the number of the train parts will be this one. Then the number of the testing part will be this one. After splitting the data into one, training and testing, we just move to the classification stage. In this classification stage, first of all, we have to predict the accuracy of the classification like 99.88%. So this is belongs to the decision tree classification. So once everything was completed, so we have to check the precision, recall and the F-score also for decision tree alone. So after that, the logistic regression was started. In that logistic regression, we have to find out the accuracy as well as the precision, recall, F-score, everything. Similar to that, the KNN classification also done to predict the accuracy, everything. After predicting the everything, the prediction results will be displayed as whether the first data is non-attack, the second data is attack, the third data is non-attack, then the fourth data is non-attack. Likewise, we can predict any datas.